Have you ever heard that old saying, two heads are better than one? Well, in the world of AI, it's kind of more like 100 heads are better than one. Today, we're going to dive into something called ensemble methods, which is really just a fancy way of saying we're going to build a whole team of AI models to make way smarter decisions than any single genius model ever could on its own. So that really is the big question, right? Is one single super smart genius model actually better than a whole team? And in machine learning, the answer is not even close. You see, every single model, no matter how brilliant it seems, has blind spots. It has weaknesses. And that's exactly where the power of teamwork comes in. We're about to see how. Okay, so before we can start putting together our AI dream team, we first have to understand why a lone wolf model, even a really powerful one, is almost always going to struggle. It all boils down to this classic fundamental tug of war in machine learning. And here it is, the heart of the problem, the bias-variance trade-off. Think of it like this. A high-bias model is like a student who just skims the chapter summaries. Yeah, they get the big picture, but they miss all the crucial details. On the other hand, a high-variance model is like a student who memorizes the entire textbook, right down to the typos. They're so obsessed with the tiny details that they can't see the actual concepts. And this visual just nails it. Over on the left, you've got that high-bias model underfitting. It's just this lazy, simple line that completely misses the real pattern in the data. Then on the right, you've got the total opposite. The high-variance model is overfitting. It's this chaotic, jittery line that's trying so hard to hit every single point that it's just modeling random noise. The perfect model is somewhere in the middle. And ensembles? Well, they're our secret weapon to get there. All right, let's get into our first playbook for building a smarter AI team. We'll call this one democratic diversity. It's all about harnessing the wisdom of the crowd to get to a much better, much more stable answer. The technical term for this is bagging, which is short for bootstrap aggregating. But forget the jargon for a second. Imagine you're at a fair and there's that giant jar of jelly beans. Instead of making one guess yourself, what if you asked 100 different people to take a guess, and then you just averaged all their answers? That collective average is almost always going to be way more accurate than any single person's guess. That's bagging. So how does this actually work under the hood? It's pretty simple, really. First, we create a whole bunch of slightly different versions of our data by just randomly grabbing samples from it. This gives each model its own unique view of the world. Then we train a totally separate model on each of those mini data sets, all at the same time. And for the final step, we just let them vote. If it's a classification problem, the majority opinion wins. If we're predicting a number, we just average their answers. Simple as that. And this is bagging's superpower. It's fantastic at taming those wild high-variance models we talked about. See, by averaging out a ton of different predictions, all the weird individual mistakes and quirks tend to just cancel each other out. You're left with a much smoother, more reliable prediction. It takes these powerful but kind of erratic models, like the deep decision trees you find in a random forest, and turns their individual chaos into a really stable collective intelligence. Okay, let's put these two head-to-head for a second, because this really sets the stage for our next playbook. As you can see, bagging is all about that parallel crowd approach to fight high variance or overfitting, but our next contender, boosting, is completely different. It uses a sequential assembly line to fight high bias or underfitting. It's a totally different philosophy for building a team. And that brings us to playbook number 2, sequential specialists. So for a minute, forget about the wisdom of the crowd. This is all about the power of learning from mistakes. Think of it like a master training an apprentice, who then grows up to train their own apprentice. Each generation gets a little bit stronger, a little more focused. And that right there is the magic of boosting. It's not a parallel process, it's sequential. Each new model that we add to the team is laser focused on one thing and one thing only, fixing the mistakes that the previous model made. It's this relentless cycle of self-improvement that turns a bunch of individually simple or weak models into one single incredibly powerful prediction engine. The process itself is actually pretty brilliant. So a first, simple model takes a shot at the problem. Then we look at all the predictions it got wrong. We take those mistakes and we tell the next model, okay, your turn, but I want you to pay extra attention to these specific examples that the last guy messed up. And this just continues on down the line, with each new model becoming a specialist at fixing the errors of the one that came before it. Now, this core idea has led to some of the most dominant algorithms in machine learning today. I'm talking about the heavy hitters. You've got XGBoost, which is basically the reigning champion you see winning data science competitions all the time. Then there's LightGBM, the absolute speed demon for when you have just massive amounts of data. And you've also got CatBoost, which is a total specialist at handling messy data with lots of categories. Okay, so we've seen the power of a democratic crowd, and we've seen the efficiency of a specialist assembly line. So for our final playbook, we're going to assemble the Avengers of AI. We're talking a team of totally different experts, each with their own unique skills, all being led by one brilliant manager. This, my friends, is called stacking, and it's probably the most complex of the three. See, instead of a simple vote or just fixing errors in a sequence, stacking uses a whole second-level model, a meta-learner, to intelligently figure out how to combine the predictions of the first-level models. It's like having a team manager who knows every player's exact strengths and weaknesses and knows precisely who to listen to in any given situation. So the game plan for stacking goes like this. First, you train your team of diverse experts, maybe a decision tree, a totally different linear model, and even a neural network. Then, you have all of them make their predictions. Now, here's the kicker. You train a final meta model, or the manager, but it doesn't learn from the original data. No, it learns from the predictions of the other models. It learns to figure out which expert to trust and when to make that final game-winning call. So what's the catch? Sounds pretty amazing, right? Well, stacking can deliver absolutely jaw-dropping accuracy. We're talking competition-winning stuff. But it can be a total beast to set up and train correctly. It's the high-maintenance superstar you call in only when you absolutely positively have to squeeze out every last fraction of a percentage point of performance. Okay, we've covered a lot. We've got bagging, the wisdom of the crowd, boosting, the assembly line of specialists, and stacking, the council of experts. The big question is, which one do you actually use? Well, as you can probably guess, there's no single right answer. It all depends on your goals, your data, and what you're trying to accomplish. And really, it all boils down to this one fundamental trade-off. If you're chasing the absolute highest accuracy possible, and you've got the time and the computing power to do it, you're probably going to be looking at boosting or stacking over on the left. But if you're building something that needs to be fast and simple, something that needs to work in real time, then a single model or a quick bagging approach on the right is often the much smarter choice. So let's be super clear. Sometimes that lone genius model is the right call. When is that? Well, when you need lightning-fast predictions, or when you absolutely have to be able to explain exactly how the model is making its decisions, or maybe when the accuracy boost you'd get from a team is just tiny, or you just don't have the computer resources to pull it off. In those cases, yeah, simplicity is king. So what's the one big idea to walk away with? We started by asking if a single genius is smarter than a team. And the answer, we've seen, is a definite no. The real magic, the secret sauce of all these methods, is what this quote says right here. Diversity. It's all about combining models that think differently and make different kinds of mistakes. Because if everyone on your team thinks exactly alike, you don't actually have a team. All you have is an echo chamber. And in AI, just like in life, the whole is so much greater than the sum of its parts.